Alright, so let's talk about trigonometry. First off, trigonometry is a branch of mathematics, right, that deals with the study of the lengths and angles of triangles. Let's take a case study. Let's say you have a right angle triangle, alright, presented like this. Let's say this is a right angle triangle. Now, if you have an angle here presented as theta, that's the angle this diagonal makes with the horizontal line, we're going to have that this theta is facing a certain vertical line here, which we call the opposite. The longest side of this right angle triangle is referred to as the hypotenuse. So these are terms which we use to define the sides of a triangle. And then the horizontal line which the angle rests on is referred to as adjacent. This line can also be vertical. Alright, so now what are trigonometric functions that we can use to relate these three terms, the opposites, the hypotenuse, and the adjacent? The first one is sine. So we have sine theta is always given to us as opposites all divided by hypotenuse. Alright, then we have that second cos theta. So cos theta is given to us as adjacent divided by hypotenuse. The adjacent still divided by hypotenuse. And the last we have is tan theta, which is given as opposites divided by adjacent. Now, these are basic trig ratios that we ought to know starting basic trigonometry. There are more complex ones, but let's start with this. Now, there is a particular mnemonic we used to remember this, which is referred to as the SOH-CAH-TOA principle. The SOH-CAH-TOA, which represents that sine is opposite divided by hypotenuse, as we said before, cos is adjacent divided by hypotenuse, and tan is opposite divided by adjacent. Alright, now what are the relationships between sine, cos, and tan? We can express tan as a function of sine and cos. What do I mean? If you divide sine divided by cos, we say sine is opposite by hypotenuse. So if we have opposite over hypotenuse divided by adjacent over hypotenuse, we'll have that due to this division, this fraction is going to flip upside down. So that's going to give, so this is equivalent to opposite over hypotenuse times hypotenuse divided by adjacent. So this, of course, have certain values which are fixed. They are the same, so you can cancel out, and what we have left is opposite over adjacent. That's opposite divided by adjacent, which we said was tan theta. So this is equal to tan theta, and we obtain tan theta as sin theta divided by cos theta. So that's what relates cos theta, sin theta, and tan theta, all three together. Now, each of these trig functions, or these trig ratios rather, have a reciprocal. So the reciprocals of each of them take different names. For example, the reciprocal of sin theta, which is now 1 over sin theta, we refer to that as cosecant theta. So refer to that as cosecant theta. Then we also have the inverse of cos theta. So we have the inverse of cos theta, refer to that as secant theta. And the inverse of tan theta, which is still 1 over tan theta, is now cotangent theta. Now, of course, if you now to express this in the values of the right angle triangle, or rather the size of right angle triangle, cosecant theta becomes hypotenuse over opposite, secant theta becomes hypotenuse over adjacent, and cotangent theta adjacent divided by opposite. So the short form of cosecant theta that has given us as You can write this as also cosec theta. The short form of secant theta is sec theta, and this is also cot theta. So aside these basic trigonometry that I've obtained, sin theta, cos theta, tan theta, their inverses and relationship that relates three of them. There is also a relationship that relates sin theta, cos theta with either of these three. Alright, so there are three of them as well. Let's talk about them. The first one is that let's write that other trigonometries we need to know before we start tackling questions. So other trigonometries. The first one we have is that sine square theta plus cos square theta is equivalent to 1. So this is very important. Right, this is a basic formula we need to know. Sine square theta plus cos square theta is 1. Let's write this as the first. Now, if I divide all through by sine square theta, let's do that. If I divide all through by sine square theta, we're going to have sine square theta divided by sine square theta plus cos square theta over sine square theta will be equivalent to 1 over sine square theta. Now, sine square theta over sine square theta is 1 plus cos square theta divided by sine square theta. Now, we have to be intuitive here. If sine theta divided by cos theta is tan theta, so mean that tan theta, cos theta divided by sine theta will become the inverse of tan theta, which we establish as cot theta. So now we're going to have no longer cot theta, now we'll actually cot square theta, which will be equivalent to the inverse of sine square theta. The inverse of sine square theta we said was cosecant theta. So that is now, we write it short form cosec square theta. So let's call this 2. This is why I call this a basic formula, because I'm going to obtain 3 from this as well. If you divide all through by cos theta, we're going to have sine square theta divided by cos square theta. Get divided all through by cos square theta rather, plus cos square theta divided by cos square theta will be equivalent to 1 divided by cos square theta. Alright, so sin square theta divided by cos square theta, that's going to give us tan square theta plus cos square theta divided by cos square theta, that's equivalent to 1 is equals to 1 over cos square theta, that becomes sec square theta. So we write this as 3. So these are 3 trigonometries that you need to know. This one relates sin theta, cos theta, tan theta, cos square theta, cosec theta, sec theta, but just that they're in square forms. Alright, so let's take some questions. Alright, so we have an exercise to tackle, and it says if sine x is 3 over 5 and 0 degrees is less than x is less than 90 degrees, which implies that x is between 0 and 90 degrees. Now, we don't have to bother much about this, it just implies that our value of x is acute. Find the values of I cos x, I tan x, I cot x, we have cosec x, sec x, and lastly sin x minus 2 cos x all divided by 3 tan x. Now, let's start with I cos x. Remember, we established a trigonometry that sin square x plus cos square x was equivalent to 1. So if we know sin x, we can evaluate cos x, right? So meaning that we can plug in our values and see that 3 all over 5, which is sin x, all squared, plus cos square x will now equal 1. So now, 3 squared divided by 5, that's the same thing as 3 divided by 25, plus cos, this is 9, 3 squared is equivalent to 9, cos square x will be equals to 1. So we have that cos square x, if we collect like terms, will be equivalent to 1 minus 9 over 25. We'll pick the LCM. This is equals to LCM is 25. Here becomes 25 minus 9. 25 minus 9, that gives us 16 all divided by 25. Alright, so we have cos square x is 16 over 25. We have that cos square x is equals to 16 divided by 25. To find cos x, we square root both sides. So square rooting both sides, we get that cos x will be equals to the square root of 16 is equivalent to 4, and that of 25 is equivalent to 5. So that's the value of cos x. So that's for question I. For the next one, we have tan x. So remember we said that tan x, and in that case it was theta, but it was the same as in this case sine x divided by cos x. They say we should find tan x. Sine x is 3 over 5. So this is now sine x 3 over 5. Put that in brackets. Divided by cos x is what? Cos x gave us 4 over 5. So this is divided by 4 over 5. 3 over 5 divided by 4 over 5. We're going to flip this fraction because of division. So we have that this is equals to 3 over 5 times 5 over 4. So we're going to cancel out 5. So that's the same. So this is now equal to 3 over 4 as our value of tan x. Next is cot x. Cot x. Now cot x is simply said is the inverse of what? Tan x. Now tan x we already got as 3 over 4. So cot x is now equals to 1 divided by 3 over 4. This fraction flips because of the division. So we have 1 times 4 over 3, which is now equivalent to 4 over 3 itself, because anything multiplied by 1 is that number. So that's the answer as value of cot x. So next we have cosec x. We have cosec x. Now cosec x is simply the inverse of sine x. So this is 1 over sine x. So sine x we already established that it's 3 over 5. They said it's 3 over 5. So this is 1 divided by 3 over 5. So the fraction flips, which is now equals to 1 times 5 over 3. So this gives us 5 over 3. So for the value of sec x, we said that sec x, which is secant x, is giving us the inverse of cos. So that's 1 divided by cos x. Now we already established our value of cos x. We got that as 4 over 5. So we have sec x to be 1 divided by 4 over 5. So the fraction flips because of the division, which will now be equivalent to 1 times 5 over 4. So that gives us our value of sec x as 5 over 4. As for vi, which is the last part of the question, they said evaluate sine x minus 2 cos x all divided by 3 tan x. Now we've gotten a value of sine x. They give us as 3 over 5. So this is equals to 3 over 5. We remove that from 2 multiplied by, we got cos x as 4 over 5. 4 over 5. If you check, that's 4 over 5. Then tan x was gotten as 3 over 4. That's 3 multiplied by 3 divided by 4. This is now equivalent to 3 over 5 minus 2 multiplied in numerator, so that's 3 over 5 minus 8 over 5 divided by 9 over 4. Alright, we'll treat the numerator first. 3 over 5 minus 8 over 5. We're going to resolve that since both are fractions, so we'll take the LCM as 5. That will become 3 minus 8, which is equivalent to minus 5 divided by 5. We can break that down. Both sides, that's minus 1. So we now have minus 1 divided by 9 over 4, as we did before. Right, as we did before, the fraction flips because of division signs. So this is same as minus 1 times 4 over 9. So our final answer becomes minus 4 divided by 9. Alright, so just talking about trigonometry function of compound angles. This basically involves the cos, sine, or tan value of the summation or subtraction of different angles. First off, let's think about when you have sine A plus B. A plus B, of course, at different angles. It can be the same as well. taking the sine value of two different angles. Now we need the expansion of this. It's a particular function. So whenever you have a trigonometry represented as sine a plus b, this can be expanded as sine a cos b plus cos a sine b. So that's for the sine value of summation of angles. But if you have a minus b, so that becomes sine a minus b in bracket, that becomes sine a cos b minus cos a sine b. Alright, so this is for the summation of angles, two different angles or the same angles of the sine value of the summation or subtraction of two different angles. Now what about the cos value? If you had cos a plus b, so this is now become represented as cos a cos b, the sign changes, minus sine a sine b, while for subtraction we have cos a minus b to give us cos a cos b plus sine a sine b. Alright, then for tan goes in a different pattern, but we have tan a plus b to give us tan a plus tan b, all divided by 1 minus tan a tan b. Then as for tan a minus b, this is going to give us tan a minus tan b, all divided by 1 plus, it becomes tan a tan b. Alright, so you have a question that says if cos a is equal to 3 over 5 and sin b is equal to 4 over 5, I said find cos a plus b, find cos a minus b, sin a plus b, and sin a minus b. So we're going to use the trigonometry compound formula that we derived before. Alright, so the first one, so the solutions we have for the first one, which is cos a plus b. First off, we said that cos a plus b, we can expand this to give us cos a cos b minus sin a sin b. Now from the question, we're given cos a, we're given sin b, we're not given cos b, neither we're given sin a, but we can get sin a and cos b. How? Now if we have that cos a is 3 over 5, they said cos a is equals to 3 over 5 and sin a is unknown. We can use the initial trigonometry we derived initially, which was that sin square theta plus cos square theta is equal to equivalent to 1. So in this case theta becomes a, so we have that sin square a plus cos square a will be equivalent to 1. So sin square a is unknown, what we're looking for. So let's write that sin square a plus cos square a becomes 3 over 5 all squared. This is equivalent to 1. So we have that sin square a plus 3 squared, that gives us 9 divided by 25 equivalent to 1. The correct items, we have sin square a to be equivalent to 1 minus 9 over 25, that gives us 16 over 25. And if you take the square root of both sides, we'll get that sin a is equals to 4 over 5. Using that same method, let's get cos. Alright, we've gotten sin a, so let's get cos b. So we have that sin square b plus cos square b will be equivalent to 1 as well. Sin square b, that's 4 over 5 all squared, 4 over 5 all squared, plus cos square b is equivalent to 1, 4 squared, that gives us 16 over 25, plus cos square b will be equivalent to 1. So we can see that cos square b is now equivalent to 1 minus 16 over 25, which is equivalent to 9 over 25. Take the square root of both sides, we have that cos square b will be equals to 9 over 25. If you square both sides, we're going to get that cos B is equals to 3 over 5. Alright, so we've gotten sine A, we've gotten sine B, they gave us sine B, we have cos A and cos B. Now we can fully implement our formula by simply substituting. Cos A was given the question as 3 over 5. Remember, I said that again. Cos A plus B is equivalent to cos A cos B minus sine A sine B. Alright, so let's substitute our values now. We got cos A as 3 over 5. So we have 3 over 5. We got cos B as 3 over 5 as well. Then minus sine A sine B, which is 4 over 5. 4 over 5. So this is 9 over 25 minus 16 over 25, which if you collect like terms, we are going to have rather the LCM is going to be 25. 9 minus 16, that gives us minus 7 as our final answer as cos A plus B. Let's take the next question. Alright, so the next question is cos A minus B. If we expand cos A minus B by the expansion we gave, we're going to have cos A cos B. This time becomes plus sine A sine B. We'll just substitute our values. Cos A is 3 over 5. Cos B is the same, 3 over 5. We now have plus 4 over 5. 4 over 5. If we multiply 3 over 5 by 3 over 5, so this is equivalent to 9 over 25 plus 16 over 25. So we have LCM is 25. Let's resolve the fractions. LCM becomes 25. 9 plus 16, that's equivalent to 25 again. So we just have to divide 25 by 125 divided itself, that's equivalent to 1 as our value of cos A minus B. As for the third question, we state that we should find sine A plus B. First we need to expand. Expanding this is sine A cos B, as we said before, plus cos A sine B. So we got a value of sine A. We said sine A was 4 over 5. So that's 4 over 5 multiplied by cos B, which is 3 over 5, plus cos A, which we got as 3 over 5, and sine B, which is 4 over 5. So 4 over 5 multiplied by 3 over 5, that's equivalent to, let's write it here. So this is equivalent to 12 over 25 plus the same 12 over 25. So we collect LCM rather, this is 25. 12 plus 12, that gives us 24. So that's our final answer as sine A plus B. So the last question says we should find sine A minus B. As we did before, we're going to expand sine A minus B, which is now sine A cos B minus cos A sine B. As we did before, we're going to plug in our values. So we have 4 over 5 multiplied by 3 over 5 minus 3 over 5 multiplied by 4 over 5. So 4 over 5 multiplied by 3 over 5, this is equals to 12 over 25 minus 3 over 5 multiplied by 4 over 5, that's equivalent to 12 over 25. 12 over 25 minus 12 over 25, that's equivalent to 0. So that's for sine A minus B, and that's for the end of the practice question. That's it for trigonometry for today.